Electrochemical CRISPR can be used for extremely quick blood tests. Part of the scientific community hope that the gene editing tool, also known as CRISPR, which will be a scientific miracle that will eradicate disease and fight cancer. Others are not so quick to sign it. Presses say it will be used to create designer babies and further widen the inequality gap. Researchers at Case Western Reserve University has been working on the different use altogether for CRISPR, a new universal biosensing point of care medical device that can rapidly and efficiently detect viruses, which is extremely fast device. In order to develop their universal biosensing device, the researcher converted the CRISPR recognition-induced enzymatic signal to an electrical signal. This allowed them to use it to detect the biomarkers for virus, which is human papillomavirus HPV or ferrovirus. This could some days become a simple, accurate, and cost-effective point of care device for identifying efficient nucleic acid viruses such as HPV or parvovirus. From a single droplet of a blood sample, Yifan Dai, a PhD candidate in the chemistry department and lead author of the paper, explained in a press release, and it would also be extremely fast. SDI explained that in existing tests for these viruses currently take up to 5 days for accurate results, and they can be costly. The biosensing pioneered by Case Western Reserve researchers meanwhile would allow for accurate results in less than an hour. It will be particularly useful in the case of viruses like parvovirus B19 or parvovirus, where 2 out of 10 people infected having no symptoms, and HPV, a common virus that can lead to sex type of cancer later in life. E-CRISPR, while CRISPR has been tested mainly for cutting and editing DNA, E-CRISPR is the name OBDI and co-author has given for their biosensing device application of the technology. The device is what they call an electrochemical platform, which relies on the presence of the CRISPR technique to identifying viruses in a person's bloodstream with incredible efficiency. The CRISPR technique works so that it cuts all of the non-specific single-strand DNA around it once the target is recognized. So we to program electrochemical probe this activity, he said. No virus, no cutting, it's that simple. And the opposite is true. If CRISPR starts to cut, we know the virus is present. If you want to read this article, I will give the link of this article in the description below.